What we're going to be learning now is how to solve a certain type of exponential equations. Eventually, you're going to learn how to use something called logarithms to solve a lot of these, but this is going to be logarithms. But we're not going to be using logarithms in this lessons over here. These lessons are going to be done solving exponential equations without this fancy thing called logarithms. So we'll start off by noting, let's say we have 2 to the x equals 2 to the 5. And it seems potentially obvious that if 2 to the something equals 2 to the 5, then the something has to be 5. So we can see that x equals 5. What we're going to say that if the bases are equal, then the exponents have to be equal. So if these are equal, then those also have to be equal. So that's equal to that. So therefore, what we know is we know that x has to be equal to 5. Okay. Now, just quickly go back over there. If we add something like 2 to the x equals 10 to the 3, the bases are not equal, and we're actually stuck. We're not going to be able to solve this thing at all. In fact, I think the answer turns out to be something like 9.9657 8. So, and there's no way to get that right. There's no way to get from this to this at this point. So we're only going to solve it if the bases are equal. Example 2. 2 to the x plus 1 equals 2 to the 7. The bases are equal. So that means that the exponents have to be equal, which means that x plus 1 would have to be equal to 7, x equals 7 minus 1, x equals 6. Which kind of makes sense. If you put 6 into there, you get 2 to the 6 plus 1, which is 2 to the 7, which is equal to 2 to the 7. And of course, we could have a fully algebraic thing going on up there. So if we have something like this, the bases are equal, shrink, shrink, which means that the exponents have to be equal. So 3x plus 7 must be equal to 5x minus 1. Move things over, minus 2x equals minus 1 minus 7. Minus 2x is negative 8, and x equals 4. Wait, did I do that right? I did do that right. Okay. And that's pretty straightforward.